This is experiment number 4, that is single layer perceptron. A single layer perceptron is the simplest type of artificial neural network. It is a linear classifier. It classifies data that is linearly separable. So it consists of input layer, which receives the features of the input, and weights are multiplied to each input, and the summation function computes the weighted sum of inputs. And there is also activation functions, which determines the output based on the sum. So the formula for a summation function is y is equal to wx plus b, where w is the weight and b is the bias, x is the input given. Activation function if it's f of z is equal to 1 if z is greater than or equal to 0, and 0 if z is less than 0. So here the code for this experiment is this is the first step where we import the necessary libraries, that is pandas, numpy, matplotlib for all the data processing, numerical calculations, and plotting graphs. And the scikit-learn library, we uh, import the train plus split so as to split the data into training and testing data, and the performance metrics. For example, the accuracy score, precision, confusion matrix, which shows how accurate the prediction is, and the for pre-processing label encoder. The first step is we are reading the CSV data into the pandas data frame. So the data set is iris.csv, and we have the features like sepal length, sepal width, petal length, and petal width. The next step is data pre-processing. So data imputation is done for the null values so that the mean value is filled into the null values. Then label encoding for converting the categorical data to numerical data. So here every column which has null values is replaced by the mean of the values. And in L is equal to label encoder. This is a function which is applied to transform all the categorical columns names into numerical values so that it is easier for the perceptron to predict the output with choosing independent and dependent variables. So in this data set, we are choosing feature columns as the independent variables, and y is the, that is species encoded, is the dependent variable. This in this line we can see that the labels are converted into -1 and 1 so that it will be easier for the perceptron to understand. The next step is we standardize the input features. The input features are like converted to mean and standard deviation. We are finding the standard deviation so as to explain how much it varies from the actual data set. And the next step is the splitting of the data set into training and testing data. So in this line, we are splitting the data into train test split. That is, testing size of the data is 30%, and the training data is 70%. This is the training data set size, and this is the testing data set size. Here, we assign the learning rate. Learning rate is how fast the model can learn about the input features given to it is the learning rate. So n iterations are 20. So 20 times the weights will get updated. And for a single A perceptron, initial weights are always initialized to 0. Then error in this code, we can see a list, an empty list to store the errors is found. And for epoch, that is one full training pass of the data set, for every epoch, it goes around 20 iterations. And to find the error, in every pass, it finds the error. If the error is large or it varies too much from the actual data, then it calculates the updated weight, and it finds the summation function for that particular weight, and then applies the activation function. After activation function, the new weight is updated. So if target value is not equal to the predicted value, then the weight is updated. So the uh, formula for the updating the weight is learning rate into target value minus predicted value. And then the final weight of each input attribute. So after running 20 iterations, 20 epochs, this is the final weight of the input attribute. A graph is plotted against the errors and the epochs. So this graph tells for every epoch how much the error is. So in the beginning, the error is so high. But as the epochs increases, the error becomes low and it becomes constant after. Then class labels are given for the value. So this is the predicted value, which a list is formed for storing the predicted value, and the predicted value is calculated. So it is 1 if the net input is greater than 0, or else it is minus 1. So it is appended into the white-red list. So this white-red list gives the output. Then we calculate the confusion matrix. These are the performance metrics and which tell us how accurate the data is or how different the data is from the output is from the actual data set. So accuracy, precision, and everything is one here, but which is the ideal case. In reality, it's not possible. There will be some deviation, but any value that is near to one is considered as to be mostly accurate, and the data is then prepared for Tableau visualization. So Tableau is used in order for data visualization, which gives us insights on how exactly the data is distributed and how accurate the uh, analysis of the single layer perceptron, and how actually correctly it has predicted the output. So we shall see the visualization in the Tableau itself. This is the Tableau visualization of the data set. Here we are using k-means clustering to cluster the data points that are similar data points. And here we see the correlation. First, we are constructing the correlation matrix between every feature, that is petal length and petal width, then the correlation between petal length and sepal length, between petal length and sepal length and petal width, sepal length and sepal width. So this is the correlation between these features, and based on those features, our data set is producing this visualization through using Tableau. So these are the clusters. This is cluster one. So there are three species of iris flower, that is Iris setosa, Iris versicolor, and Iris virginica. So, depending on the similarities between the features, the clusters are formed using k-means clustering. So, this shows petal length, petal width, sepal length, and sepal width of this particular Iris setosa species of flower. And this is Iris versicolor, and this is the image of the flower. And this is Iris virginica. So the data visualization tells how accurate and how different the features are. and the similar features or similar flowers are grouped together. Thank you.